Bismillahirrahmanirrahim. Uh, Find the hybrid parameters for the two-port network shown in figure 1, and this is the figure 1 given to us. So before we find the hybrid parameters, let us discuss and define the hybrid parameters. So the hybrid parameters are defined by the following equations. Hybrid parameters. So hybrid parameters are defined by these two equations. So V1 is equal to H11 I1 plus H12, the second parameter, H12 V2, and here I2 is equal to H21 I1 plus H22 V2. So these are called hybrid parameters because unlike admittance and impedance parameters, all the parameters are not the same. With impedance parameters, all the parameters involved are impedances. And in the admittance parameters, all the parameters involved are admittances. But here, some of the parameters, one parameter is impedance, one is admittance, and the two are unitless, and which are gains actually. So we can write this equation like this also. V1 I2 in matrix form is equal to H11 H12 H21 H22, right? And here we have I1 V2. So these are the H parameters. We can write it like this: H11 H12 H21 H22. So for example, if we put V2 is equal to 0, if V2 is equal to 0, then we have V1 is equal to H11 I1, and this defines H11 to be equal to V1 divided by I1 while V2 is equal to 0. And similarly, when V2 is equal to 0, I2 is equal to H21 I1, right? And this term is 0. And then we have H21 is equal to I2 divided by I1 while V2 is equal to 0. And now if I put I1 is equal to 0, if I1 is equal to 0, then these two terms will disappear, and then V1, for example, is equal to H12 V2, and from here we can see that H12 is equal to V1 divided by V2 while I1 is equal to 0, right? And from this equation we have I2 is equal to H22 V2, and then this means H22 is equal to I2 divided by V2 while I1 is equal to 0. So this is how all these four hybrid parameters are defined. So you see that H11 is obtained when V2 is equal to 0. The output port is short circuited at that time. To put V2 is equal to 0, we short circuit the output port. So this is the short circuit parameter, and this is equal to H11 is equal to V1 divided by I1. So this is short circuit input impedance, right? And then H12 H12, we obtain H12 when I1 is equal to 0, that the current at the input port is 0. So to put the current input I1 to 0, we open circuit this input port. So this is an open circuit parameter, right? And this is open circuit, and H12 is equal to V1 divided by V2. So this is basically reverse voltage gain. Open circuit reverse voltage gain, right? And then H21 here is obtained when V2 is equal to 0, right? So this is again a short circuit parameter. Short circuit, and this is forward current gain. Forward current gain. And last of all, H22. We obtained H22 by putting I1 is equal to 0. So this is the input is opened. So this is open circuit parameter. So open circuit, and this is I2 divided by V2. So this is admittance here, output port admittance. Output admittance. So as you see, two parameters are open circuit parameters. Two parameters are short circuit parameters. One parameter is impedance, one is admittance, and these two are unitless, these are gains. So this is why these are called hybrid parameters. So now to the given circuit, to find out the hybrid parameters for the given circuit, we can imply a number of techniques. We can set V2 is equal to 0 first, right? And short circuit this and find the remaining two parameters H11 and H21, and then to find the other parameters H12 and H22, we can put I1 is equal to 0. We can short circuit the input port and find the other two parameters. Or we can imply circuit analysis techniques to basically arrive at two equations which are of the same form as these two equations. Let me put this as equation 1 and let me put this as equation 2. So if we can arrive at two equations which are similar to these two ones, so then we can compare our equations with these equations, and by comparison of the coefficients we can find the hybrid parameters. So let us use this second method. So let me call this this is V1, right, and this is I1, and this is I2, and this is V2. So if I imply, for example, KVL here, so KVL in left loop, right? So this is minus V1 plus 2I1 plus 6I1 plus I2 is equal to 0. So this is I2 flowing in this direction, so I1 and I2 have the same direction when flowing through 6 ohm. So that is why this is I1 plus I2. So then this become minus V1 and plus 6I1 plus 2. This is 8I1, and this is plus 6I2 is equal to 0. Right? So let me call this equation 3. So note that we can write this equation by inspection as well. So the total resistance in this loop is 8 ohms. So the impedance, the coefficient associated with I1 is 8, right? 8I1, and the impedance or the resistance shared by I1 and I2 is a 6 ohm. So the coefficient for I2 will be 6 ohm, and as I2 flows in the same direction as I1, so the sign will be positive here, right? And now KVL, and note that this equation involves V1, I1, but I2 here instead of V2. So if we eliminate I2 and replace this with the V2, we will have an equation which is of the same form as this equation number 1 here. So from comparison we can get the parameters h1 and h2 then. So let's first now apply KVL in right loop. So this is minus v2 plus 3i2 plus 6i1 plus i2 is equal to 0, right? And this is minus v2 plus, this is 3i2 plus 6i2, so that will give us 9i2 plus this is a 6i1, right? 6i1 is equal to 0. So let me call this equation 4. And we could also write this equation by inspection. This is minus v2, and the total impedance or the resistance in this second loop is 9 ohms. So the coefficient of I2 is 9, right? And the resistance shared by I1 and I2 is a 6 ohm, and they both flow in the same direction, so the sign is positive here, 6I1. So if you note that this equation involves the same parameters which this equation has, the second equation. So I2, I1 and V2. So I2, I1 and V2. So if we rearrange this equation in this form, so we can then obtain the parameters H21 and H22 quite easily, right? But before we do that, let us eliminate I2 from this equation. And if we find the value of I2 in terms of I1 and V2 then, so I1 and V2, so this will be then replaced by V2 here, right? V2 here. So from this, let's find the value of I2. So 9I2 is equal to V2 minus, so V2 minus 6I1, right? And I2 is equal to V2 minus 6I1 divided by 9. So that is equation number 5. So putting this equation in 3, putting 5 in 3, so this is minus V1 plus V1 plus 8 I1 plus 6, and that is now we substitute the value of I2 here. So V2 minus 6 I1 over 9, and that is equal to 0, right? So multiplying throughout by 9, multiplying by 9, we get this is minus 9 V1 plus 72 I1 plus 6 V2 minus 6 into 6, 36, I1 is equal to 0. So let us revisit this again. So multiplying throughout by 9, so this is minus 9 V1 plus 72 I1 plus 6 V2 minus 36 I1. So we can now further improve this. So this is minus 9 V1, and this is 72 I1 minus 36 I1. So 72 minus 36 gives us plus 36, right? So plus 36 I1 plus 36 I1, and we have plus 6 V2, plus 6 V2 is equal to 0. So we can write this in terms of this form here, in this form. So 9 V1 is equal to, first we will have the I1 term. So this is 9 V1 is equal to 36 I1 and plus 6 V2. So let's divide dividing both sides by 9. So V1 is equal to 36 over 9 is 4I1, and 6 over 9 is 2 over 3 V2. So this is the first set of equation of this form, and let me call this equation number 6, right? And we can rearrange this equation 4 here in this form. So this equation involves V2, I2 and I1, right? So from equation 4, we have we need to write this in this form. On the left side we need I2, so 9I2. Let's put 9I2. 9I2 is equal to 9I2 is equal to minus 6I1 plus V2, minus 6I1 plus V2. So I2, dividing both sides by 9, so that will be minus 6 over 9, so that will be 2 over 3I1, right? And plus 1 over 9 V2. So this gives us our second equation, which is of the same form as these two equations. So comparing 6 and 7 with 1 and 2 respectively, comparing 1 and 6 and 7 with 1 and 2 respectively, we can obtain the h parameters, right? So we can write them directly in the matrix form. So h11 is 4, and this is 4 ohms, right? So this is for V1 divided by I1, so this is 4 ohm. And then we have h12, this is 2 by 3, but this is unitless because this is a ratio of voltages, right? So this is V1 divided by V2. And then we have h21, and this is also unitless, minus 2 over 3, and this is I2 divided by I1, right? And then we have 1 over 9, and this is a Siemens, right, admittance, because this is I2 divided by I2 output admittance. So these are the hybrid parameters that we need for this circuit. So this was one method to find the parameters. We can imply an alternate method, which is the standard method, alternate method, standard method, right? Why I call this a standard method? Because this method, if the circuit is a bit complex, we may not imply this technique directly to that complex circuit. If it involves more than one node and it has many loops, for example, then maybe we will need to imply the standard method to find the hybrid parameters. So what we do in this standard method is we use this technique. We put off V2 is equal to 0 first and find these two parameters h11 and h21, and after finding these parameters we put off I1 and set it equal to 0, and then find the remaining two parameters h12 and h22. So let V2 is equal to 0. So that is the output port is short circuit. So let me redraw the circuit here. So this is a T network, right? So we short circuit this. So V2 is equal to 0, and this is the current I2 flowing in. This is the voltage source V1, and we have resistance 2 ohm. 2 ohms resistance here. This is 6 ohm, and this is 3 ohm. and let me call this fig 2. Fig 2. So and this is current I1 here, right? So as you see, 6 ohm, 3 ohm resistances, these are in parallel. So let me call this Z1 for example, or Z1, right? So Z1 is equal to 6 in parallel with 3. So that is 6 multiplied by 3 divided by 6 plus 3. So that is 18 over 9. So this is Z1 is equal to 2 ohms. Right? So this 2 ohm is in series with this 2 ohm resistance here. So we can say that V1 is equal to 2 plus 2. This 2 ohm and this 2 ohm parallel, the combination parallel, the equivalent resistance of this parallel combination 2 ohm multiplied by I1. So V1 divided by I1 while V2 is equal to 0, and this should be equal to, as we see, is H11, right? So this is H11. So H11 is equal to 4, and this is ohms. So this is short circuit input impedance. So we have found one parameter, and the other parameter that we can find here is H21, because V2 is equal to 0. So we can find H21, and H21 is equal to I2 divided by I1 while V2 is equal to 0. So we can imply a current division here, current division rule at this side. So using current division, we can see that I2 is equal to, so this is current flowing through this 3 ohm, right? And this will be, we need to find current flowing through this 3 ohm. So that is 6 divided by 6 plus 3. The parallel combination, right? 6 plus 3 into the total current. This is I1. And as the direction is opposite to this I1, so we can put a negative sign here, right? So we can see I2 divided by I1, I2 divided by I1 is equal to minus 6 over 9, 6 over 9. This doesn't have a unit. 6 over 9. So I2 divided by I1 while V2 is equal to 0, and this is, while V2 is equal to 0, this is H21, right? So this is H21, this is equal to minus 2 over 3, right? And this is the same parameter that we obtained here. So we have found these two parameters. Now to find the other two parameters, we need to put I1 is equal to 0. So now we put I2 is equal to 0. So let I1, not I2, I1 is equal to 0. So in that case, let me redraw this circuit again. So this is right. So this is I1, 2 ohm. This is V1. This is open, right? This is open circuit, and there is a voltage source here. And this is 3 ohm. This is V2, and this is 6 ohm. So the first parameter that we can find when we put I1 is equal to 0 is H12. So H12 is equal to V1 divided by V2. Let me call this fig 3. H12 is equal to V1 divided by V2 while I1 is equal to 0. So there is a source connected here. This is V2, right? And this is open circuit. So to find the voltage V2 in terms of V1, we can apply the voltage division rule here. So using voltage division, so we can express this V1 in terms of V2, right? So V1 is equal to, so as this is open circuit, so this is out of the circuit, and this 3 ohm and 6 ohm are in series, right? And the V1 is the voltage across 6 ohm resistance. So 6 divided by 6 plus 3 and multiply by this total voltage V2. V2 is across both 3 ohm and 6 ohm which are in series. V2, right? So that is V1 divided by V2 while I1 is equal to 0, and this is H12, and this is equal to 6 over 9, and that is 3 into 2 6 and 3 into 3 9. So we have found the third parameter as well, and to find the last parameter H22, we see that this is current I2. So we see that V2 is equal to 6 plus 3 into I2. So the last parameter is as this is 6, so V2 is equal to 9 I2. The last parameter is I2 over V2, output admittance. I2 over V2, and this while I1 is equal to 0, and this is H22, and this is 1 over 9 Simons. So again we have arrived at the same set of parameters using the alternate method, the standard method. So the same set of parameters are again here, and let me again write them down. This is the first parameter that we found, 4 ohms. Then we found out minus 2 over 3, this parameter, the forward current gain. Then we found out 2 over 3 here, right, reverse voltage gain, and then output admittance 1 over 9 Simons. So this completes the solution to this problem.